Welcome back to Math Solver 1117. Today we are diving into problem 2 from the 2024 International Mathematical Olympiad. A simple looking question that puzzles some of the world's brightest young minds. Think you can crack it? Let's find it together. Question is, determine all pairs A B of positive integers for which there exists positive integer g and n such that greatest common divisor a raised to power n plus b and b raised to power n plus a is equal to g holds for all integer and condition is small n is greater than or equal to capital N. Note that greatest common divisor xy denotes the greatest common divisor of the integers x and y. We will solve this question in very easy and simple way, step by step, so you can tackle question like this. So first of all, understand the condition. Condition is that the GCD a raised to power n plus b into b raised to power n plus n is equal to g for all n small n is greater than or equal to n, which implies that g must divide both a raised to power n plus b and b raised to power n plus a. So we will solve this for case 1, case 2 and case 3. We will write the case. Case is that a is equal to 1 and b is also equal to 1. We will put this, so we will get, then greatest common divisor is 1 raised to power n plus 1 and 1 raised to power n plus 1, which is equal to the greatest common divisor of 2 and 2, which is equal to 2. So in this case g is equal to 2 and the condition holds for, this condition holds for small n is greater than or equal to 1. So we can say that 1 and 1 is a solution. Now we will solve the case 2. So according to the case 2, condition is given for case 2 that a is not equal to 1 or b is not equal to 1. Any one is not equal to 1. So assume that we will assume that a is not equal to 1 or b is also not equal to 1. Both are not equal to 1. When both are not equal to 1, from the properties of greatest common divisor, we know that greatest common divisor of xy will be equal to the greatest common divisor of x into y minus k of x. Condition will be like this for any k belongs to z, matlab k is an integer. So greatest common divisor of a raised to power n plus b and b raised to power n plus a will be equal to the greatest common divisor of a raised to power n plus b and b raised to power n plus a minus a raised to power n plus b dot k. This is the value of x. We will apply this formula here. So if g divides G divides the G divides an plus b and bn plus a, so it must divide the difference of both of them, also divides a into b raised to power n plus a and minus b into a raised to power n plus b, which will be equal to the abn plus a square minus b a raised to power n minus b square. So this is divisible for all integers of g for small n is greater than or equal to n. Now consider the large value of small n. Now we will consider large n. For large n value, we will take the situation as if a is greater than 1 and b is also greater than 1, then an and bn grows very rapidly. So we will say that GCD of a raised to power n plus b and b raised to power n plus a will be a constant g, and it implies that a very specific relationship between a and b. So without loss of generality, we will suppose if a is not equal to b, assume that a is greater than or equal to b. As n approaches to the infinity, its mean a raised to power n plus b is also approaches to infinity and b raised to power n plus a also approaches to infinity. For the greatest common divisor to be a constant, it implies that the term must be related in a way that their common factor remains the same. So now we will use the properties of divisibility on this, that if g divides the g is taken as common from a raised to power n plus b and g is taken common from b raised to power n into a, then this implies that g also taken common from a raised to power n plus 1 plus b and b raised to power n plus 1 plus a. We can take g also common from this, which implies that we have from this g raised to power an, we have a is congruent to the minus b and mod of g, and from this one we have b raised to power n is equal to the minus a mod of g. Now we will substitute the value a raised to power in this equation. We will get a raised to power n plus 1 plus b is equal to 0 mod of g, and we get a into minus b plus b is equal to 0 mod g. And in this way we will take the common of b from this. So b is taken common, remaining is 1 minus a, which is equal to congruent to the 0 mod of g. So now we will discuss 3 cases of this. We will discuss that if g into 1 minus a, b into 1 minus a is congruent to the 0 mod of G and A is taken common, remaining is 1 minus B is congruent to the 0 mod of G. So there are three cases. First one is if A is equal to the 1, then 0, when we put A is equal to 1, so 0 mod 0 G, and this is true. Second one is if B is equal to 1, then this will also 0 is equal to 0 mod of G, and this is also true. Third case is if A is not equal to 1 and B is also not equal to 1, then G must divides which thing? B into 1 minus A and A into 1 minus B. Now consider that we have A is equal to B. Condition is this. So we will get GCD of A raised to power n plus A and A raised to power n plus A will be equal to A raised to power n plus A, and take A common, you will get A raised to power n minus 1 plus 1 from this. For this to be a constant, G must be constant. To get G constant, this value should be constant for all n raised to power greater than n. This is only possible if A is equal to the 1, and if A is equal to the 1, then we get G is equal to value of G. This is 1, so 1 plus 1 2. So value of G will be 2. This lead to the solution of 1 and 1. We have find out in the case 1. Now consider another case when A is not equal to B. This is for another. So if A is not equal to B, we have condition. Then if A is equal to 1, we get GCD as 1 raised to power n plus B and B raised to power n plus 1. So for this to be a constant G must divide 1 plus B. So 1 plus B or B raised to power n plus 1, we will say that B raised to power n plus 1 will be equal to the congruent to 0 mod of 1 plus B. So from this case we have B is congruent to minus 1 mod of 1 plus B. Then we can say that B raised to power n plus 1 is congruent to minus 1 raised to power n plus 1. This is the condition, and mod will be 1 plus B. For minus 1 raised to power n plus 1 is always divisible by condition is 1 plus B and n is greater than or equal to 1. We need to be divide 1 plus B to 0 if n is odd and even. We consider both. This implies that 1 plus B must divide 2. So if 1 plus B divides 2, which implies that we have two cases. 1 plus B is equal to 1 or 1 plus B equal to 2. So if it is equal to 1, we get B is equal to the 0, and in this case we get B is equal to 1. So this leads to the back of the solution 1 and 1. Again we get 1 and 1. So conclusion of this is The only pair of A and B for which condition holds is 1 and 1. So we will write the final answer of this is 1 and 1. If you found this video helpful, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. In the next video, we will solve more interesting Olympiad maths problem. Stay tuned. Best of luck for your exams.